Hello, I'm ETarte, math teacher. This is a solution video to my math challenge, triangle and rectangle. In the challenge we have an equilateral triangle, meaning that all three sides are the same length, and inscribed in it we have this rectangle with height exactly twice the width. And so I called the width n and the height 2n. And I had two questions. What is the length of one side of the triangle in terms of n, and what is the ratio of the rectangle's area to the entire area of the triangle? Well, the basis of the solution is the 30-60 right triangle. Every angle of an equilateral triangle is 60 degrees, and if you have a right triangle with the other angles 60 degrees and 30 degrees, as shown here, the simplest example is the short leg has length 1, the hypotenuse has length 2, and using the Pythagorean equation, the longer leg has length the square root of 3. So I'm going to apply that relationship to this 30-60 right triangle in the lower left-hand corner of my diagram. This triangle. If we take the entire side of the equilateral triangle and call it S, and we subtract n, that leaves us with these two, and each is half of that. So this length, this short side of the 30-60 right triangle, is S minus n divided by 2. So I write the proportion 2n over S minus n over 2 equals the square root of 3 over 1. So there's the proportion, and I will now solve that proportion for S. To do that, I first cross multiply, which gives me the square root of 3 times S minus n over 2 equals 2n. I multiply both sides of that equation by 2, and I distribute the square root of 3 on the left side, and I get S times the square root of 3 minus n times the square root of 3 equals 4n. I add n root 3 to both sides, and I have S root 3 equals 4n plus n root 3. On the right side, I factor out the common factor n, and I divide both sides of the equation by root 3, which gives me a good answer for S in terms of n. S equals n times 4 plus root 3 divided by root 3. I can write the answer in another good way by rationalizing the denominator, that is, getting rid of the root sign of the denominator. I do that by multiplying this expression by 1. I write 1 as root 3 over root 3, and I get another good answer. S equals n times 4 root 3 plus 3 over 3. So that answers the first question, giving the length of one side of the triangle in terms of n. Now the other question in the challenge is to find the ratio of the rectangle's area to the area of the entire triangle. Well, the area of a rectangle is its base times its height, and that's n times 2n, which is 2n squared. That's the area of the rectangle. Now, for the area of the equilateral triangle. The area of a triangle is 1/2 its base times its height. So that's 1/2 its base, which is the expression we got for the side in terms of n, times the height. Now the height is based on the 30-60 right triangle relationships. It is all this times the square root of 3. So I have copied this but inserted the multiplier, the square root of 3, right here. So this is an expression for the area of the triangle, and I now need to simplify this expression. I have rewritten the expression as n squared times root 3 times 4 root 3 plus 3 times the same thing, 4 root 3 plus 3, all over 36. In that expression, I multiply 4 root 3 plus 3 times itself by the FOIL, F-O-I-L method, and I get this expression in parentheses, 48 plus 24 root 3 plus 9. The 48 and the 9 add up to 57, and so I have this new expression for the area of the triangle, n squared root 3 times 57 plus 24 root 3 all over 36. In this expression, 57, 24, and 36 are all multiples of 3. I can factor out the 3 from the expression in parentheses in the numerator and divide both numerator and denominator by 3, and I get this new expression. The area of the triangle equals n squared root 3 times 19 plus 8 root 3 over 12. I distribute the root 3 to the expression in parentheses, and I get what is probably the simplest version of the area of the triangle, n squared times 19 root 3 plus 24 over 12. So I asked for the ratio of the rectangle's area to the entire triangle's area. It is this fraction, the rectangle's area, which is 2n squared, over the triangle's area, which is this expression that we just got. And when you simplify this, the 12 ends up as a multiplier alongside the 2. The n squareds cancel. So we have this final expression for the area of the rectangle over the area of the entire triangle. 24 over 19 root 3 plus 24. My calculator tells me that an approximation for that expression is 42 hundredths, meaning that the rectangle has an area that's approximately 42% of the area of the entire triangle, which seems reasonable. And so there you have my solution for my triangle and rectangle math challenge. Thank you for watching this solution video.